There's time for another flashlight, and today I will take a look at this one. It's a $1 flashlight from eBay. So I will take a look at it and also compare it with the flashlight from my other video. So this one was for $1 and the last one was for $2. So what we can get for $1? It's a small flashlight, it's smaller than the other one. And it also uses different type of batteries. There's a space for a battery and it seems to be 1 AA size, or it's kind of loose inside, but it seems about the size of AA battery. And now I'm not sure if it's for the classic 1.5 volt AA battery or for the AA size, the lithium-ion battery is 3.7 volts. But it's always safer to begin with the 1.5 volt one. Let's put it into the flashlight, screw it back, and it seems to work, so it's probably for 1.5 volts. And it has a clicky switch here. This one has only one mode, so it's only on or off. The housing is completely made of aluminum with a black finish, just like this one. But this one is not zoomable, it's just one piece of aluminum. And there's the LED. I can see like a yellowish phosphorus, so it's a cool white one. The warm white ones have orangish phosphorus. So this is just entirely one piece of aluminum from here to here. So I cannot open it here, it's not zoomable, and so I'm thinking about how I am going to open it up. There's a contact inside, there is a spring, and it says police 3 watts. And in the listing it was called 2000 lumens. So let's make some calculation. If it had really 2000 lumens and the power was 3 watts, then it will have about 667 lumens per watt. And that's just crazy, because the best LEDs in the world have about 160 lumens per watt. And before we open it up, let's measure how much does it draw. I will check if this is just a switch without any resistor in it. And it really seems there's just a switch. So I can actually replace it with my current meter. And it draws about 250 milliamps. So it actually draws 0.25 amps at 1.5 volts. And this is 0.375 watts. So that's nowhere near the 3 watts it says. And because it is running on 1.5 volt battery and the LED needs about 3 volts, there must be some boost converter, some joule sieve or something like this. And the current through the LED would be, because the LED needs about 3 volts, the current would be I equals P over U, and it is 0.375 watts divided by 3 volts, and the current is 125 milliamps or 0.125 amps. And this is if the converter was 100% efficient, but the actual current will be lower because no inverter has 100% efficiency. And because I'm afraid the disassembly will be destructive, let's compare the brightness first. This is the $1 one and this is the $2 one. And you can see the difference. And now I'm really not sure how do I open it up, so I have prepared everything from this tool to this tool. So let's remove the battery, and here I can see some contact and board, and there's the plexiglass. Can I press it somehow? No, I can't. Can I press it out from this side? And this is gonna be tricky. And this is just one piece of aluminum. And that's definitely gonna be a destructive disassembly. Let's remove the plexiglass. And there's the reflector. Can I get it out? Okay, the reflector is out. And there is some LED, and it really doesn't look very powerful. It almost looks like a traditional 5mm LED. And that's disappointing. And there's a spring. It's spring loaded in it. And it's out. So what we have here? There's the contact, some wire, and LED. How do I open it up? Okay, there's a board, and it contains just the contact and nothing else. And there is some inverter with an inductor. So far I can see one inductor and one SMD transistor, or maybe a chip. And there's really nothing else, just the LED, inductor, and transistor, which probably is not a transistor but a chip, because with just single winding you cannot have a self-oscillating joule sieve. A joule sieve requires 2 windings, so this is probably some integrated chip. And the circuitry still works. It really doesn't seem very powerful. There is just tiny LED soldered into a board with absolutely no heat sinking. This is just ordinary board without any aluminum core. And this seems to be really just a 5mm ordinary LED, which usually is rated for 20 to 30 milliamps. And as I calculated, this is being driven at 125 milliamps, so it's about 4 or 5 times the maximum current. That's just horrific. That's the typical Chinese way of driving LEDs. And I have reverse engineered the schematic of it, and it's really super simple. There's just the battery, switch, some chip and inductor to boost the voltage to basically step up to 3 volts for the white LED. And there is not even any rectifier, so it's basically powering the LED with high frequency impulses. And according to my homemade frequency meter, it runs at more than 300 kHz. And I'm especially interested what is the current of the LED. And because there's a high frequency current, I will have to put a capacitor in parallel to the multimeter. And that's about 93 milliamps. And because this is just a standard 5mm LED without any heat sinking, rated for about 20 to 30 milliamps, this is gonna die very soon. And what about my rating of those flashlights? This $2 one was absolutely excellent, but this $1 flashlight is just absolute rubbish. This is Diode Gone Wild, and see you in my next videos.